I wanted to review a little bit about factor trees and prime factorization because these skills show up in a lot of different kinds of problems. And if you are familiar with how to use these, you can use them in a lot of different ways. So the first thing we want to know is a factor tree is basically a way of splitting up a composite number, like for example, 30, and breaking it into smaller factors. And factors, in this case, we're looking for whole numbers, positive numbers, that multiply to give us 30. And so the first thing I want to do when I'm making a factor tree is I can think what times what gives me 30. And it doesn't matter what I pick. So anything that comes to mind will work. So I could say 30 I know is 3 times 10. And so if I do that, on each branch of my tree, I'm basically going to follow it down. And now I look at 3 and I say, okay, can I break 3 into anything smaller? Can anything times anything else give me 3? And the answer is 3 is prime, which means it's only 3 times 1 that would ever give me 3. And so if I get a prime number, I'm going to circle it. So we circle the primes. And that will be the end of that branch of the tree. So then I look at the next branch, and here I have 10, and I say, okay, what times what gives me 10? And I say, okay, I know 2 times 5 gives me 10. And then I look at each of those branches, and I see that 2 is also prime, and 5 is also prime. And so once every branch has a circle at the end of it, I'm done. And then I write my prime factorization by putting only the circle numbers in my answer. So only the circled numbers. And I'm going to put them in order from smallest to largest. And they're all going to be multiplied. So what that looks like for this is that I say 2 times 3 times 5 gives me 30. And that is called the prime factorization of a number because it's all the primes that you can multiply together to get that number. And you can check it by just multiplying. So you could say 2 times 3 gives me 6, 6 times 5 gives me 30, and it works out. Now, the nice thing about factor trees is you could do it multiple ways and you will still get the same answer. So I'm going to show you another way we could have done 30. I could have said, okay, 30 I know is 5 times 6. And then I would look at 5 and I'd say 5 is a prime number, so I'm going to circle it. And then I would look at 6, and 6 is not a prime number, so that means I can break it into smaller prime numbers. So 6 is 2 times 3, and I would circle those. And you'll notice that even though they're in a different order, I end up with the same 3 numbers circled. And when I'm writing my prime factorization, I'm always going to put it in order, smallest to largest. So I would still get 2 times 3 times 5 equals 30. And the really cool thing is every number, so let's say every whole number, right? Which means not the decimals, not the fractions. Every whole number has a unique, and unique means one of a kind, prime factorization, which means that any number from 1 to like 7 million and beyond 7 million, every number has its own prime factorization. Technically 1 doesn't because 1's too small, but starting at 2 actually. So the prime factorization will either be different prime numbers multiplied together, or if there's only one of them, that only happens if it already is a prime number. So let's look at some examples of this. So prime factorization of common numbers. So the first thing is there are ones that are just primes, right? So primes we're not going to put in the prime factorization category because they're just primes by themselves. So primes are 2, 3, 5, 7, 11, and so on. Now what that means is any number not on this list could be written as a product of primes. So composite numbers can be written as a product of prime numbers. So I have 2, I have 3, which means 4 is my first composite number. And 4 is just 2 times 2. Then I have 5 over here, so then I have 6 next. And 6 is just 2 times 3. Then I have 7, and here I have 8. And 8, if you can do it in your head, you can. But also, if you're like, I can't do that in my head, this is where the factor tree helps, right? So if I had 8, I could break it into 4 and 2. And I know 2 is a prime number, so I circle it. 4 gets broken up further into 2 and 2. So I circle both of those. So 8 is 2 times 2 times 2. 2 times 2 times 2. And then 9 is not on this list, right? So 9 goes over here. And 9 we know is just 3 times 3. And then similarly 10 we know is just 2 times 5. 11 is prime. And then 12. So again, 12, when it starts being a product of more than just 2 primes, it can be hard to do without writing it out. So 12 we could write out just to show you. And 12, you can actually break it up multiple ways, right? So I could say 2 times 6 gives me 12. So I know the 2 is there. I break the 6 up further, and I say 2 times 3 gives me 6. So that could be one factor tree for 12. And the other factor tree for 12 could be if I say, well, 12 is 4 times 3. And then I say, okay, I know 3 is prime. And then 4 is a product of 2 and 2. And 2 is prime, so I circle both of those. And in both of these cases, you'll see that you end up with 2 times 2 times 3 gives me 12. And then 13 is prime. 14 ends up being a product of primes. So if you're looking on your list of primes, you can say 14 is 2 times 7. So 2 times 7 gives me 14. And then 15 is, if you're looking on your list of primes, you say 15 is 3 times 5. And so this is a really cool way to break down any composite number into smaller numbers that multiply to get you there. And you can keep going like this for basically all of the numbers. 16 is another one that tends to be hard to do in your head, but you can think, how is 16 related to the numbers on here? And if you know that 16 is just double of 8, then you take 8, which was 2 times 2 times 2, and you multiply it by 2 again, and you get 16. So 16 is 2 times 2 times 2 times 2. And if that confused you, don't worry about it. You could also make a factor tree. You could say 16 is 8 times 2, 8 is 4 times 2, 4 is 2 times 2, circle your primes. Or you could say 16 is 4 times 4. Oops, we don't circle the 4. That's a mistake there. We do 16 is 4 times 4, and then we break 4 into 2 times 2. We break this 4 into 2 times 2. And in both cases, we get 2 times 2 times 2 times 2. And that gives us 16. So you can basically take any prime number, multiply it by another prime number, and you'll get a composite number. And you can take any composite number and multiply it by another prime number, and you'll get a different composite number. Once you have these, you can find the greatest common factor and least common multiple really easily. So I'll show you that another time. But for right now, I just wanted you to know that factor trees are super helpful. And for any number, you can break it down. And it doesn't matter which way you break it down, because you are always making the problem simpler as you keep going. And so there's no wrong way to do it. You'll always end up with the correct answer. You just have to put them in order.